All right, so we're going to go over the solutions to the tossing the rock and up down the hole problem. All right, so how high will it go? I've listed out my givens here, paying careful attention to the signs. So if my initial velocity is up and up is positive, then I need to make sure that anything that is directed down must be negative, including my gravitational acceleration. You must have that negative sign in there. So now we need to pick an equation. So the question is, find the missing variable. So I have got all positions. I need to solve for velocity. I have acceleration. The thing that's not in this list, and I'm not even being asked about, is t. So t is the missing variable. So you want to pick an equation that doesn't have t in it. So I'm going to go with our v squared equation, which is the last one. And I'm just going to write it out, our change in position. And this is really a change in y, and it's perfectly fine to say a change in y since we're looking at something that's vertical. But I'm going to keep it as change in x for now. And our final velocity for how high it is going to go is our speed at the top, which is going to be 0. I set that equal to my initial velocity squared, 28 squared. And then I'm going to put my negative sign in for my acceleration in front. So I have the 2. There's the 10, but it's really that negative 10 right there. And then my final position is what I'm solving for, and my initial position is 0. So remember, change in position is minus initial. So I'm going to solve for this, bring this over. So 28 squared is 784. So if I bring that over to the other side, I'm going to get minus 784 on this side, minus 20. Equals minus 20 times x. And if I solve for my position at the top, I'm going to get 39.2 meters. So don't forget your units, circle your answer. So I've done all the steps, and this is what I expect on WebAssign. Show an equation, a substitution, and a final answer with a unit. All right, what is the object's velocity as it hits the ground? So again, have the list of givens that we discussed already. Now I want to find this final velocity when it ends at this position. So when I write, again, don't care about time. Time is missing, not asked about it, don't care about it. That's the missing variable. So I'm again going to use that v squared equation. I'll write that out there. And this time I'll write change in y. What the heck? Sometimes you might even see this as g times y. That's also acceptable to write it that way already and kind of substitute the g in for the a. So occasionally you'll see that as well. But remember, this change in position is going with this velocity. So if my change in position is going to be 10 meters below where I started, it goes with, this is the initial velocity that goes with this initial position, and the final velocity goes with this final position. So there's a correlation between the variables between the initial and the final. So final velocity squared is what I'm solving for. My initial velocity, again, is 28 squared. And then I'm going to put in the minus. I'll put the plus in this time. Oh gosh, I'm running out of space here. 2. And this is going to be really squishy. I don't like that. I don't like that. 2 times minus 10 in there. So let's write that big. I'm sorry, this is just awful. 28 squared plus 2. My acceleration is minus 10. Final position is minus 10 meters minus my initial position, which was 0. Now I have this all right. So again, I'm going to have the 784. And then I have 2 times minus 10 is 20 times another minus 10 is plus 200, and that's going to be equal to my velocity squared. So take the square root of both sides, and you're going to get plus or minus 31.4 meters per second. Now you need to conceptually analyze, well, is it positive or negative? Well, if I'm looking at hitting the ground, then I have to choose the negative solution. So negative 31.4 meters per second is the velocity that it hits the ground. And of course, the speed would be 31.4. All right, now we seem to be concerned about time. So we're going to look at time. So how much time does it take to take the rock to complete its trajectory? So that means the whole up and the down part. Well, I know an initial velocity and I know a final velocity. I can list those because I solved for it in my previous part. So my initial velocity is equal to plus 28 meters per second, 28. My final velocity is equal to minus 31.4 meters per second. My acceleration is going to be equal to minus 10 meters per second squared. And of course, that is pretty simple that I can use this equation. Hopefully it jumps right at you. And of course, you can write it this way. And sometimes I see people write it B naught minus GT because they're kind of implicitly putting that in there. But I tend to just kind of leave it like this, but then make sure you put your negative sign in there. So 28 minus 10 times T that is going to be equal to my final velocity. Final velocity, which is minus 31.4. Draw that, all that great. And solving for t, we're going to get 5.9 seconds. All right. All right, we're going to go through this last part, which is find the position of the rock at t equals 3 seconds. So that is my question mark. I know that my acceleration due to gravity is minus 10 meters per second squared. And I'm writing all of this out just for completeness. There is no expectation on your web assignment that you keep listing out the givens. But if you're stuck on a problem and you ask for help, you should have at least gone through this set of exercises of listing givens, drawing a picture, trying to map it out. Okay, what else we got? We got time is equal to 3 seconds. We got that situated, and we know our initial position is equal to 0. So again, what is the missing variable in this list of equations? Well, v. I don't care about the velocity at t equals 3 seconds, so v is missing. So that's going to tell me which equation to use. I'm going to pick the one that doesn't have v in it. And if you quickly glance through, it would be that fourth equation that we've been talking about, which is my change in position is equal to my initial velocity times the time plus 1/2 the acceleration times time squared. Substituting in my variables, my position is what I want to solve for. My initial position is equal to 0. Initial velocity is 28. Time is 3 seconds. I'm going to put, I'll just keep it in like that, 1/2, and then I'll put the minus 10 there. Sometimes I like to put the minus sign out here. And then t squared is 3 squared. So substituting all that in, we get that our position at t equals 3 seconds is about 39 meters, which kind of makes sense because if you think about it, our initial velocity is 28 meters per second. So it's going to take roughly 2.8 seconds to get to the top. So if we go a little bit past that, if we notice the position at the top was a little bit more than 39 meters, 1 second later, it's a slightly below that. So it kind of makes sense that is our answer. So you guys should all be ready to kind of jump into the WebAssign now. And again, make sure if you're struggling that you draw a picture, label it, decide on direction. All these things are going to help you be successful in problem solving.